So this is the third part, and I uh, I learned a little bit on this one. I've done mark and recapture before, but the method was different. So I'm going to learn something on this one. I can't wait to see how good it works. Okay. So what do? You take a bowl. I decided to get a beaker. Seemed proper. You get a bowl and you put all your white beads in there. Okay. And then you grab another bowl and you put all your colored beads in there. And what you do to begin with is you choose to take out a known number of beads from the bowl that has only white beads in there. Okay, that number is somewhere between 10 and 25. You choose whatever you want it to be. Personally, I took out 18 white beads. 18. Okay, so I took 18 white beads. I put them in a different bowl, which is another beaker. And what I'm going to do is I'm going to replace those 18 white beads with 18 colored beads. So if you took out 20 white beads, you would replace it with 20 colored beads. If you took out 10 white beads, you would replace them with 10 colored beads. Okay, so here's my original population. Here's my 18 beads. I'm going to pour them in there. Okay. And I don't think this is going to work. Okay. Fortunately, I have a little bag here. Because I can't live without coffee, so I've got my Burger King creamer bag here. And what I'm going to do is I'm going to take my population of white beads with my 18 color beads, and I'm going to put them in the bag. Okay. And before I forget, I need to put the initial number of marked beads at the top of my data sheet. So I put 18 on there. Notice that. Okay. And now what do? Now what we're going to do, we're going to shake it. And we're going to take out a sample of the population that is between 25 and 40 beads. Between 25 and 40 beads. Okay. So I'm going to look at my sample here. Let's see, one. Oh, this is so much fun, I got to tell you. Let's see, one. I'm going to start with my white beads. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So that's 28 white beads and 3 colored ones. Okay. So here, the data that I have to put is total beads in the sample captured. Well, I have 28 plus 3. So the total number is 31. I captured 31 beads. And of those, the number that were marked were 3. Only 3 of them were marked. And I've got Excel to calculate the percentage for you already. you're welcome. Okay, now what do? Now you take these beads, you throw them back into the bag, and shake it again. Okay, we get to do this 20 times. Exciting. Let me tell you, this is exciting. 11, 12, 13, 14, 15, 16, 17, 18, 19. So this time I caught 19 plus 1. And I'm in trouble because I didn't get my lower bound. I got to throw them all back. I didn't get 25. I got to get 25 or more. Take it, take it, take it, take it. Got to make sure I grab enough. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This time I have 23 plus 3, 4, 5, 6, 7, 8, plus 8. 3, 4, 5, 6, 7, 8. Okay. So total number captured that time was 31. That was amusing. 31. Number of marked beads, 8. 8. Now what do? We take them. I'm going to do one more and then I'm going to pause so I can do the rest because, well, what else can we do? 15, 16, 17, 18, 19, 20, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So it's 40, and I went over. Uh-oh. Got to throw them back in. You got to have a proper sample size. Try it again. I'm afraid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 24. Okay, that's 24 plus 4. That gives us 28 plus 4 is 32. 32 plus 4 is 36. 36 plus 4 is 48. That'll work. 28. And the number of captured was 4. Okay. And so on and so forth. Okay. So I'm going to pause right here, and I'll come back when I've got the whole thing done. Very well. I just finished my 20 iterations, and I also counted all the white bees in my original population, and I came out with 182. Okay. These are my percentages. I'm just going to turn these percentages into, I'm going to lower the decimal points. So here under home, number, and decimal points, I'm just going to decrease that to probably 0, like so. Down here are my averages. This should go down to 0, 2. This should go down to 0, 2. Okay. I'm going to go ahead and bold this because this is the relevant data at the very bottom, the average. And now we're supposed to estimate the population size. Okay, so over here I'm going to put estimated population size. And the calculation says original number times the average number captured. So this is the number captured. This is my average number of captured, and then we're going to divide that by the average number of marked individuals captured. That's going to be this number right here, and that should give us an estimated population size. So I can't wait. I'm just so fascinated. Okay. So in Excel, we're going to do an equal sign to let it know that we're doing math. Original number marked, I put them right up here. It's 18. I'm going to multiply that by average number captured. So I'm going to click on cell B23. And then I'm going to divide that by number of marked individuals, average number of marked individuals we captured, which is this guy right here. And my estimated population size, if I go down to the nearest whole bead, is 154. My actual is 182. So let's do a percent calculation. We'll go percent error. Let's make sure that all these go to are right justified. So let's see. Right justify them, like so. Okay, percent error. We're going to do an equal sign. We're going to do the absolute value, that's ABS, open parentheses. Then we do the correct value, which is this one, minus the experimental, close parentheses, divide, okay, by the correct value, and then we're going to multiply by 100. So our percentage error was 14.4%. This is not impressing me at all. I actually have another recapture motif that takes a lot less work and gives you much better estimates than this. I'm actually pretty disappointed with this. With 20 iterations, we should be at 5% or less easily, and we're not. That is just terrible. Oh well, it is what it is. We're going to highlight all these like so. You're going to put your mouse right in the middle of two columns like that until it turns into two arrows. Double click. That may, oh, sorry about that. Let's move this out of the way. Let's move this box out of the way. Okay, let's try it again. There, that's better. Now I'm going to move this box back. There we go. And everything's going to be centered because that's the way it should be. Centered. Boom. Beautiful. Okay, so this is table number 4. And we're going to highlight these 3 numbers because this is the important outcome. And we're going to go through D down to that. We're going to copy. We're going to bring our Word document back up. And we're going to insert data table 4 right in here. And so far I've been choosing the first option. So I don't see why I would change this time. Boom. And then remember, we click on this little square in the upper left-hand corner, and then we center our table. That looks really good. And you know what I'm going to do next, right? You know. I'm going to highlight my rows. I'm going to press and hold Control down, highlight the rows going down, because in science, presentation matters. People think that scientists don't care. We care a lot. So in fact, the purest science of all, which is physics, has that a solution should be symmetrical and it should be elegant. That's a high demand. But what that's telling you is that science is beautiful. Okay, let go of the control, right mouse button, table properties, borders and shading, down arrow on the fill, choose a pretty color like blue, go OK and OK, and look at that. Doesn't that just look beautiful? And then you have your 3 questions at the bottom. Okay, so that's what it should look like. And I know this was a lot of bean counting, guys. I feel really bad about that, but hey, you know what? The reason I didn't back away from this is because environmental science, you do a lot of bean counting. You are out there counting birds, you're counting frogs, you're counting fish, you're counting bears, you're counting wolves. You're always counting something. So inevitably, if you ever were to become an environmental scientist, bet that you're going to end up carrying out one of these methods of population estimates. Okay, so that's it. I hope this helps. I hope you have a wonderful day. Thank you.